Hello dear students, welcome to Konar classes. Today we are going to discuss Bayes theorem. This is one of the greatest application of conditional probability. Before going into the details of Bayes theorem, so let us understand the motivation behind learning Bayes theorem by means of couple of examples. Okay, think about that you have two bags. Two equally likely bags has been given to you. Okay, suppose we give the name is the first bag as bag 1 and the second bag as bag 2. In the first bag, think about there are 3 white balls and 4 black balls, and in the bag 2 there are 5 white balls and 6 black balls, and all the balls are equally likely. That means if you keep your hand into any of the bags, okay, you will not able to make the difference by touching it, that which one is a white ball and which one is the black ball. That is what in the mathematical term is known as equally likely and mutually symmetrical. Why it is equally likely? Because all the balls are in the same shape, size, and mutually symmetrical. That means you are not able to differentiate, okay, that which one is the black ball and which one is the white ball just by touching it. And both the bags are of the same size. Okay, in front of you both the bags are here. Now if you put your hand in any of the bag and if you take a ball, so this ball could be either white or black, correct? Obviously. Now Bayes theorem is going to help us to answer this type of question. Suppose you keep your hand into one of the bag and you do not know which bag you put your hand, okay? You are not aware of, okay? Suppose your eyes are completely tied up so that you are not able to look that which bag you are actually touching. But you put your hand in any of the bags and then take out a ball, and after that it turned out that the ball is a white ball. Now if the question is that what is the probability that this white ball came from the second bag, the Bayes theorem is going to answer this type of question. Okay, let me give you another example. Suppose a doctor is visiting his clinic, and the doctor visiting his clinic either by means of bus or by means of his own car or by means of an auto, for example. These are the 3 mode of communication. Now every time the doctor reaches that clinic, he is late. Okay, so suppose one day the doctor came to the clinic and it is observed that the doctor is late. Then the answer, if we ask a question, that if we ask a question, the doctor is late today, but what is the probability that he came by bus today? So this kind of question if you have, then Bayes theorem is the perfect one to answer these questions. Okay, now for that, if you look into the previous example, that there is a 2 bags containing that white and black balls, and the number of balls. Okay, similarly when doctor is coming to the clinic, if he is coming by bus, and what is the probability that he is late? Suppose it is P1, and when the doctor is coming by his own car, suppose the probability is P2 for being late by coming by his own car, and suppose P3 be the probability of the doctor coming late when he is coming by auto. Then one thing is sure, that doctor when he is coming to the clinic, he cannot come by both bus and auto, or he cannot come by both auto and his own car. It has to be one at a time, right? So that means all these events of coming by bus, events of coming by auto, or events by coming by his own car are pairwise disjoint. Okay, and doctor is coming by any of this, by means of any of this mode of communication, either by bus or by auto or by his own car. So then it is actually exhaustive as well. That means there is no other event possible by which the doctor is coming to the clinic. So in Bayes' theorem, the fundamental thing is that the events has to be mutually exclusive, or you can say it is pairwise disjoint, and it has to be exhaustive. So now I already gave you the two examples and the question, and Bayes' theorem is going to answer these questions. So look into the details video description. Look into, I provided another YouTube link where the details of the mathematical derivation of Bayes' theorem has been done. Thank you very much. Bye bye.